All right.
I messed up on the ribs.
Let's see here. Yes. Oh, thank you. Take those. Yes. Thank you. All right. So again, this material will be on Thursday's quiz. On Friday, it was all about solving quadratic equations, which are degree 2. Today, we're going to look at how we can then solve equations of degree 3, degree 4, right? Cubics, quartics. I guess they're called quintics, you know, so on and so forth kind of thing. All right? The main idea is still going to be the same or similar to quadratics in that, right, we want to be equal to 0, we want to factor, and we want to take advantage of that zero product property, right? That's kind of like our main focus here. But there are some other tools that we can use along the way that will help us when it comes to factoring, right? Because factoring is kind of like a nebulous term. It can mean lots of different things, right? I mean, it has a basic meaning of just like, you know, factoring is like dividing and stuff like that. But like how you factor can be, you know, you can use lots of different strategies to factor. And so today we're going to add some tools to our toolbox when it comes to factoring, or at least remind ourselves of some of the tools that we have when it comes to factoring. All right, and the first tool that we'll talk about, one of the main ones we'll be using, right, is GCF, which stands for greatest common factor. All right, and we'll just see an example of that here. So as an example, right, let's say our directions are just something as simple as, you know, solve for x, okay, which itself, right, is, I don't know if it's unclear what to do, right? When you just see that word, solve, the phrase solve for x, you have to kind of be able to discern what strategies to use, right? And so this is, again, part of the difficulty here. It's not going to tell you, oh, solve this by using the greatest common factor, or solve this by, you know, doing some other technique, right? You need to discern what strategy to use in a particular problem. But a good place to start whenever you're going to solve an equation is see if you can factor out a GCF, right? Or at least, whoops. Supposed to be a plus there. There you go. Okay, so 3x to the fourth plus 10x cubed plus 8x squared equals 0. Right, so here we have a polynomial, degree 4, right? And we're looking to try and solve this thing for x. Okay, so yeah, Cameron.
You can factor out x squared.
Right, so we have a GCF here of x squared, right? Okay, the largest thing that can divide all three of these, we can divide all three of these things by x squared. And so we factor out, now let's say, for example here, that maybe we're bad, you know, maybe we missed something, we weren't paying attention, and let's just say we only decided to factor an x out here. That's okay, you can still factor an x out, it's not wrong. It'll look something like this when you do that. Okay, right? You didn't factor out the greatest common factor, but you did factor out a common factor, and that's okay. Right? Because if you do factor something out, and if you look back in to the thing you factored, you're like, oh, wait a minute, there's another x I can factor out here, right? You can still do that. If we factor another x out, it's going to go out with this x to multiply, or multiply and make x squared. And that leaves then the 3x squared, the plus 10x, and the plus 8. Right? So do check back to make sure that you did factor out everything that you possibly could. Right? Is there a greatest common factor for our numbers here? Thank you. Is there a greatest common factor for our numbers here? So we shake our head no, right? Because the answer is, well, it's 1, right? But 1's not helpful, right? So really we say there is no number other than 1, right? So at this point then, how should we proceed? What should we do here? We factored out a GCF, but now what should we do? Joshua?
Just factor.
Factor? Okay, so what else factors here?
Oh, what do you mean, just like how it normally factors?
I guess what do you mean when you say just factor? So what should I do? What are you going to do next here then?
Break it down into 3x plus 4 times x plus 2.
Aha. So we'll factor the quadratic that we now have. Yep, exactly right. I didn't want to assume whatever you're going to say, so I just wanted to make sure that, yeah. Okay, so yeah, so the 3x and the x, right, we need to multiply to make 8, but then with the 3x and x we have to add to make the 10 there. And so you said it was 3x plus 4. Thank you, Joshua. Sorry, I wasn't paying attention earlier. Or wasn't ready to write. And then x plus 2. Okay, great. So this now, well, since we factored out that GCF, we now have a quadratic that can then factor. Okay, and so we have 1, 2, 3 things being multiplied together, but they equal 0. So that means that either x squared has to equal 0, or 3x plus 4 has to equal 0, or x plus 2 equals 0. Okay. We'll square root both sides here for the x squared and get just x. Now when we square root both sides, normally we put a plus or minus in front, right? But 0 is not positive or negative, right? And so we don't have to worry with a plus or minus 0. That's just kind of a silly thing to write. And then this will solve to x to the negative, x equals negative 4/3, and this solves to be x equals negative 2. And so there are our solutions to the equation. Okay. If you don't believe me, right, you can check each one of these by plugging them back into your polynomial. All right. I know it can be kind of a pain in the butt sometimes to rewrite these. So let's just check like negative 4/3, for example. That's maybe a more interesting one because it's a fraction. All right. Remember what you can do here is you can type negative 4/3 in your calculator. Okay. You can hit enter if you want to. And if you'd like, you can. Oh, actually, let me change something here real quick. Okay. You can then store STO that takes your answer here and puts a little arrow and then in for x. Like that. And so now anytime I use x, right, it uses negative 4/3. So then if I want to check here if 3x to the 4th plus 10x cubed plus 8x squared is 0, I can literally type that in. 3x to the 4th plus 10x to the 3rd plus 8x squared, and we do get 0. Okay. So so now anytime I use x on my home screen, it's going to be using that negative 4/3 value. If I go to use x here in my y equals screen, it'll just use x like it's like a normal variable kind of thing. But on my home screen, now x will always be negative 4/3. But of course, you can change that if you want to. You can make it like, well, we have like negative 2. So negative 2 store x, and then I can hit, because my calculator, I can go back up here, hit enter, and I get 0 again without having to retype everything and stuff like that too. So anyway, it's an easy way to check. Your choice then. Okay. Questions on any of that? Just to show you how to use that piece of technology you got there for more than just adding and subtracting and multiplying and dividing. All right, let's try another one. Oops. This other strategy we're going to learn here is called grouping. Okay. Grouping, factoring by grouping. So let's take a look here at that. Again, we'll just say solve for x is our generic directions there, are our generic directions there. And x cubed plus 5x squared plus 4x plus 20 equals 0. Okay? So, is there a GCF here we could factor out? Is there a greatest common factor? Something that's in common to all 4 terms? Yeah, no, right? The biggest thing we can factor out of all that is 1. Not very helpful. Okay. And it's a cubic, so we really can't factor it like it's a quadratic. So we'll do this grouping thing, all right? Grouping is really helpful if we have like an even number of terms. So let's see here. We'll group together the first 2 and the last 2. Okay. It's typically helpful to do, if you're doing grouping, to write things in descending order. Okay, so descending order, highest power, next highest power, next highest power, next highest power, on down, okay? And then group like that. All right, so let's see here. So from this first group, now do I have a GCF to pull out? X squared, yeah. And what's left behind? X plus 5. Yep. Okay. What about from the second group here? What can we factor out? A 4. And that leaves another x plus 5 behind. Okay. And it's at this step that it's crucial. All right. This is our little check here to see. Is factoring by grouping a good strategy? Yes, because we end up with x plus 5 and x plus 5 here. Okay. Some problems, you'll like group them, and you'll see, oh, I can factor something out of this, and oh, I can factor something out of that. But if you don't end up with the same leftover here, x plus 5 and x plus 5, factoring by grouping does not work. Okay, and so you have to like abort mission and try something else. All right. But since these both have an x plus 5, we can now factor that common factor of x plus 5. We'll pull that out. Kind of like imagine undistributing it. Pull it out to the front here. Okay. And so if I factor an x plus 5 out of this, what's left over? X squared. Okay, and if I factor an x plus 5 out of this, what's left over? A 4, yeah, plus 4. And again, we're still equal to 0. Okay. And so we result in two things being multiplied, and they're equal to 0. So that means either x plus 5 equals 0, or x squared minus 4. Oh, sorry, x squared plus 4 equals 0. And so x equals negative 5. Or x squared equals negative 4, which is imaginary. So we can ignore that. If you put x equals plus or minus 2i there, that's not wrong. Okay? But again, we're keeping it real for right now. All right. Questions on that? All right, we'll do one more of these, and I'll have you guys try one, okay? Do one more here together, and then we'll have you guys try one. Can I move this? Is anyone still reading it, using it? Anyone still need that? Okay. Moving on. All right, let's look at 2x to the 4th plus x cubed minus 10x squared equals 5x. New. Okay. So, Rebecca, you got an idea for us here about what the very first step should be?
Factor?
Not yet.
You have to move 5x.
There we go. So, yep, subtract the 5x over first. Okay, so there, you've got that. Thank you, Rebecca. All right, let's go to Caitlin. I was going to call on you, but since you just got back in, we'll skip you there for now. All right, how about Adam? Adam, what do you say there? What should be our kind of like next step here?
You group them.
Okay, you want to factor by grouping?
Yeah.
There's another strategy we could use before it, but factor by grouping is not wrong. We could do that. What other strategy could we also use here, just as a hype? We could also factor out a GCF here. So what would you prefer to do, Adam? Do you want to factor out the x? Just do grouping? Okay. So Adam, let's go just straight for the grouping here. So we'll group the first two, group the last two together there. Okay. From that group of the first two there, Adam, what can we factor out? X to the third. And what's going to be left behind?
2x and then 1.
Very good. And a 1. Very important there. We put that 1. Right? If you factor something, by itself, a 1 is still left behind there. Don't forget that. All right. Adam, how about this from the second grouping would be a good thing to factor out?
Wait, wouldn't you have to wouldn't it just be negative 10x, but there would be a plus in between?
Okay, so you want to make it plus negative 10 like that? Okay, that's fine. What should we factor out from here?
Just make it negative 5x.
Okay, we'll factor out a negative 5x. And so what does that leave behind in here?
2x and 1.
Plus 1. equals 0. Bless you. Okay, so, right. Instead of having that minus 10x squared there, it's not a bad idea to make that plus negative 10x squared. Yeah. Okay, not a bad idea. Okay, very good. Thank you, Adam. All right, so then how about Joshua? What now?
Then I'd combine the negative 5x and the x to the third.
So yeah, we're going to take out the 2x plus 1s, factor those out, and that'll leave behind then the x cubed minus the 5x, or plus negative 5x if you like there. That's what you mean right there, right?
Yeah.
Mm-hmm. Very good. Okay. And then Joshua, what should we do from here?
And solve it.
Yeah, solve it, right? So what would I write then next?
Then negative 1/2.
Okay, x equals negative 1/2. Yeah. So I'm going to back up one step from that. But yes, you're right. It will be then x equals negative 1/2. I'll set that factor 2x plus 1 equal to 0. That means x equals negative 1/2. And we'll set this factor x cubed plus negative 5x equal to 0. Ooh, and how do I solve that one? What should we do here? Yeah.
Take an x out.
Yeah, factor out an x. Exactly right there, Liam. So we'll factor out an x, and we have x squared minus 5, or plus negative 5, equals 0. Okay, and so then Liam, now what?
Make x equals 0, you make x squared minus 5 equals 0.
Very good. And so x equals 0, and x equals the square root of 5, right? Wrong. Plus or minus. Right, because we square rooted both sides to get that root 5 there, right? So it's plus or minus root 5. Okay. And those are our solutions. All right. Question on that? Okay. All right. Let me give you one to try then. All right, so y'all try this one. Let's see here. 3x to the third minus 6x squared. Sorry. 3x to the third minus 6x squared plus 2x minus 4 equals 0. Okay. Go ahead and give that one a try. Like 30 more seconds. 30 more seconds. Okay. Let's go to somebody I haven't heard from yet. All right, how about Ben? What do you say there, Ben? What'd you do?
So I factored by grouping.
Factor by grouping, okay? Yeah, from the first group, what'd you take out?
3x squared.
3x squared, and what was left behind?
X minus 2.
Okay, and how about from the second group there?
I factored that 2 and then left x minus 2.
Great, and that's good news, right? We got x minus 2, whoop, and I'm frozen there, there we go. X minus 2 and x minus 2. That's indicating that we're on the right track, okay? And so then we can factor out that x minus 2, leave behind 3x squared plus 2 equals 0. All right, and so what are our solutions here then, Ben?
I got x is equal to 2.
X is equal to 2. That's it. Exactly right. All right, you set the x minus 2 equal to 0. Let's get x equals 2. That's where that comes from right there. Okay, but then this 3x squared plus 2 equals 0, right? You know, if x squared equals negative 2/3, which when you go square root that, it's going to be imaginary, right? So again, we can kind of like stop there, all right, and just say it's going to be 2. X equals 2. Questions on that? Ben, well done there. That's right. Okay, just 2. Just 2. Okay, let's take a look then at another strategy. One more strategy here, and the most difficult one, to be sure. Okay, the most difficult one. Okay. Substitution is one way to think about this. You could also maybe name it like change of variable. That's another way to kind of think about it too. So how do we use it? What does it look like? All right, well, same directions apply here. Solve for x. Okay. And again, notice here, there's no indication, no hint about what strategy you're supposed to use or what strategy to use, right? So you, again, part of your development you want to be developing here is not just that you can do the strategy, but knowing when a strategy applies, right? And when you do want to use a particular strategy and stuff. So here's a different problem. And one easy way to kind of like figure this out is kind of just use process of elimination, right? You kind of start with, well, can I factor a GCF? Can I, factor by grouping? That's so on and so forth. What should be our very first step here? Subtract 65 from both sides. Yeah, got to be equal to 0, right? That's like crucial for all the stuff we've been doing here. Is that right? I did. Okay. Now, is there a GCF to factor out here? No, 1, right? That's it. So nothing really helpful. Can we factor by grouping here? Not really, right? We have an odd number of terms. And so, we could group things, right? I could group together the first 2 terms and factor out an x squared, but it wouldn't be helpful because I'd still have an x squared minus 21 and then a minus 100 here, and that just wouldn't quite work out right. So factor by grouping is also not really helpful, right? And so it's like, well, what do we do then, right? Well, let me show you something here, right? If we take x to the 4th, that's the same as x squared squared, right? And then minus 21, well, there's that x squared again, minus 100 equals 0, right? Or maybe put in a different way, we have something being squared minus 21 times that something, that same something, right? Both of these are x squareds that were in here in the little blanks. I'll put like little blanks there. And then minus 100 equals 0. What's the format of this problem? What's that format? It's quadratic. It's quadratic. Okay? So even though this thing that we have right here is not a quadratic equation, right? It's to the 4th power. It's a quartic. It can kind of be rewritten in the format of a quadratic equation. And so that means it should factor to 2 binomials. Okay? The first 2 are going to be that blank. right? Because the blank times the blank will give us that blank squared there. And now we need to look for two numbers that multiply to what? Negative 100 and add to make what? Negative 21. So what are the two numbers that do that? Multiply negative 100, add to make negative 21.
Negative 25 and 4.
Negative 25, positive 4. So minus 25 plus 4. Okay. But what goes in those blanks? X squared does, right? It's x squared in this case. So we took something that wasn't a quadratic, but could be kind of manipulated, changed to look like a quadratic, and we then factored it as if it was a quadratic. And now, can we factor any further here? Yeah, Liam?
You do x plus 6 minus 6. Or x minus 5, x plus 5.
There you go, right? X squared minus 25, that's a difference of squares. What about x squared plus 4? Do we have a rule for a sum of squares? No, we don't. So it has to stay that way. Okay, so we get x minus 5 equals 0. We get x plus 5 equals 0. We get x squared plus 4 equals 0. So x is 5. X equals negative 5. And x squared equals negative 4, which we know is going to be imaginary. So there are our two solutions there. Okay. So that was a little weird, right? A little bit funky. Okay. So as for why we call this like a change of variable, like a substitution here, right? So let me show you just an alternative way to think about this. At this step right here, what you can kind of do is define a new variable. I'm going to use the variable u. I'm going to say let u equal x squared. So if u is x squared, that means instead of having x to the fourth, which is really x squared squared, I can just use u. Right? U is x squared squared. Minus, and then not 21x squared, I'll put minus 21u, then minus 100 equals 0 like that. And then you can might maybe even more easily see the quadratic here and see, aha, it's going to be, u minus 25, u plus 4, and then I have u minus 25 equals 0, and u plus 4 equals 0, which means u is 25, or u is negative 4. Okay, so this is the change of variables part. Okay, but of course the issue here, right, is are we trying to solve for u? We'll take your silence as a no. We're trying to solve for x, right? So what can I put in place of u? X squared. And so again, we square root both sides here. That's going to be imaginary. X square root both sides here. We get x equals plus or minus the 5. So there are answers again in a different way. Okay, so a different strategy there for you to use if you like. Okay, different way to think about it. This method here of like doing a substitution, changing your variables, using like a u, okay, to then rewrite into a format that we're familiar with, that is a strategy that you will use later in calculus should you decide to pursue, beyond pre-calculus into calculus and stuff like that. Regardless of whether you choose to take ABE or ABBC, you'll see. So either level of calculus you take, you'll see this show up again. Okay, the u substitution idea. Okay, not so much for factoring. It'll be more for like trying to match a function to a particular rule so that you can then like do stuff with it and stuff and all that. But I can't talk too much about it because you don't have the context for it. But anyway, there's that idea. Okay, so questions on that? This is probably the most uncomfortable one that we've had to do, but maybe you guys are just too good. All right, let's do one more here together, and then I'll have you guys try one on your own. Alrighty? So last one here together, and then you guys will have one on your own. So same directions here. I'm not going to bother rewriting them. Okay. So take like a couple seconds here, maybe 10 or 15 seconds. Just take a look at this. Think about what you would do for your very first step, and I'm going to call on someone. Okay. Drink it in there. All right, so Cameron Clark, what would be a good first step here?
Factor out the x.
Very good. We have a GCF. Okay, which would leave behind what?
3x to the 4th minus 5x squared minus 12.
Okay. Very good. Is there any more that we could factor out there? Yeah, no, that's the GCF. You factored it out. Okay. So at this point, again, it's kind of up to you. You could divide the problem up now and say, aha, x is equal to 0, and then solve, there you have a solution already. And then 3x to the 4th minus 5x squared minus 12 equals 0. So you can like divide the problem up now if you want to. Or you can leave it all together and then just solve at the end. It's up to you. I've written in pen, so now this is the way we're going. All right. So then, can we factor this by grouping? No. Okay. So we just learned that, maybe we can factor things like they're quadratics here. So let's see, maybe this thing will factor like a quadratic. Was anyone able to get it to factor like a quadratic? No. Yes. Well, we'll need a 3x squared and an x squared here, right? Because those will multiply to give us 3x to the 4th. But Mr. Whitmire, what if I had like 3x cubed and x to the 1 here? Wouldn't those multiply to give me 3x to the 4th? Yeah, they would. The problem though is that when you put numbers here, you'd have like well, let me just write it out here. If you wrote this, okay, if you wrote this out, the problem is, right, that you then have 3x cubed times a number, and then another number times x to the 1. You'd have x to the cube and x to the 1 in your problem, but you need x squared. And so that's why both of these have to be x squared, so that when you multiply by your numbers and combine like terms, you end with that negative 5x squared. But the question is, right, what two numbers go right here? Yeah.
Plus 4 minus 3.
Okay, so 3x squared plus 4,
Yeah.
x squared minus 3 like that. All right, let's check it out. 3x squared times x squared, 3x to the 4th. Plus 4x squared minus 9x squared, negative 5x squared. 4 times negative 3, negative 12. Looks good to me. Okay, so we get 3x squared plus 4 equals 0. X squared minus 3 equals 0. So x squared equals negative 4/3, imaginary. And x squared equals 3, so x equals plus or minus the square root of 3. Okay, so 3 solutions there. 3 real solutions. 0, and then positive root 3, and then negative root 3. All right. Questions on any of that? I did kind of like jump over the substitution part there, but I mean I can do it too. So, ready to try one on your own? I'll take your silence as a yes. So here we go. Okay, here's one for you to try. Okay, so 2x to the 6th minus 19x cubed plus 9 equals 0. Now let's get this up. Okay, so there's one for you to try. So see what you can come up with there. See what you can come up with there. Camera question. So, not quite, because you can't distribute square over addition and subtraction, right? This, what you wrote here, would be this thing times itself, which requires something like ridiculous boiling point.
Not 2x squared.
Yes. Okay. So if you're a little stuck, I'll give you a hint. This is going to factor like a quadratic eventually. This will factor like a quadratic. This is in a quadratic form. And maybe I'll give you even a little bit more help than that. Let's see here. Okay, so I'll give you maybe that to help you out there. One more minute. One more minute. One more minute. Okay. Anyone want to volunteer their answer there? Liam, what'd you say?
I get cube root of 1/2 and cube root of 9.
Cube root of 1/2, cube root of 9. All right. Sounds good to me. Should I put a plus or minus in front here? Right, no. Cube roots, right? Cube roots, they can be positive. You can take the cube root of a positive. You can take the cube root of a negative, right? It's square roots or fourth roots or sixth roots, any of those even power roots. But here, we don't need to worry about a plus or minus, okay? The cube root of a positive number will be a positive answer. Cube root of a negative number will be a negative answer, right? So we just do that. Did anyone simplify the cube root of 1/2 at all? All right. Although you thought about it, Quinn, you're like, nah. Kind of, yeah. So just to refresh your memory, not that you need to, right? These are fine answers, but if you just to refresh your memory a little bit, to take the cube root of a fraction, all right, you can take the cube root of the numerator and divide it by the cube root of the denominator, right? So you basically can break the cube root up over division, all right? Likewise with multiplication, but not likewise with addition and subtraction. So you can't break a cube root or a square root or any root up over addition or subtraction, but you can for multiplication and division. Cube root of 1 is easy. It's just 1 and then over the cube root of 2. Okay? Did anyone have teachers that were like sticklers for rationalizing stuff? Not really? Okay, so then, well, anyway, I won't bother rationalizing then. All right, so there's that. Okay. Rationalizing cube roots can be a little funky too. And if you're really curious about how you would rationalize that, then I can just show you that. Or if you want to know what the word rationalize means because you've never had to do it before, I'll be happy to tell you about that too. I'll rationalize it after I let everyone go because I'm not sure that everyone, Quinn, is interested in it. But I'll be happy to show you if you want to. Okay, I'll show you. Okay. I'd rather give everyone a chance to start on the homework if they want to. Okay, so that's all I've got for you. Any other last-minute questions for me before we get started on the assignment? All right, so your homework is on Google Classroom. I'd like you to go ahead and get that out and get started on it. You have a good 25 minutes. Wow. To get get it done. Let's use that time wisely. Okay, yes, question. Yeah, 1 second.